For this formula, that is simply area total times x sub g is equals to the summation of areas times x. So for area total, based on our diagram, we have here this one. So that simply shows a trapezoidal shape. So if we make use of the formula to solve for the area of our trapezoid, that is simply 1/2 of summation of its bases times its height. So we have here 1/2, and for the base 1, that is simply 160, plus base 2, which is 80, times its height, which is 80. So that gives us an answer of 9,600 square millimeters. And what is this small letter a? So that is simply area, smaller area broken down from the total area. So as you can see in our screen, we have here a trapezoid, and which we can further broken down into smaller areas. We have here this one, which gives us 3 congruent or 3 similar triangles. So we can just simply name this as triangle 1, triangle 2, so for this one, triangle number 2. So for the error, we have here triangle number 1. Again, sorry for the error. We have triangle number 1, we have triangle number 2, and we have triangle number 3. So based on the diagram shown, since these are 3 similar triangles, I can just simply assume that area 1 is simply equals to area 2 equals to area 3, and the formula for the area of triangle is simply 1/2 base times height, and its base is simply 80 times its height of 80 as well, times 1/2, and that gives us a value of 3,200 square millimeter. So right now, we need to solve for the distances. And as a review, this distance is simply from the centroid of the polygon or the triangle to the axis it is reckoned. So in our example, we reckoned the centroid of our triangle from the y-axis. And we need to take note that in a triangle, the centroid is simply 1/3 of its height if it is from the base, and 2/3 of its height if it is from the apex of our triangle. 2/3 here, and 1/3 from the base. So right now, I need to indicate here the centroids of these triangles. So I can just simply assume that these are the centroids of our triangle. So this one is 1/3 of its height, which is 80, and that gives us a value of 80 over 3, or 26.667 mm. And for this one, since we reckoned this centroid from our y-axis, so I can just simply say that this is 2/3 of the height of the triangle, that is 2/3 of 80, and that gives us a value of 160 over 3, or 53.33 mm. So again, for our x sub 1, which is simply equals to x sub 3, that is 26.667 or 80 over 3 mm. And for our x sub 2, that is 160 over 3 mm. And right now, since we all have the values for our x and for the area and for the total area as well, now we can solve for the x sub g, or the x coordinate of our center of gravity. So all we need to do is to substitute these values. So we have here area total of 9,600 times the x coordinate of our center of gravity times the area of triangle 1, which is simply 3,200, and its x distance from the centroid of the triangle to the axis it is being reckoned, which is equals to 80 over 3. For area of triangle 2, same 3,200, and its x is 160 over 3, plus for triangle 3. Then for this one, we can solve for the value of x sub g, which is simply the location of our center of gravity. So for x sub g, that gives us a value of 320 over 9 mm, or 35.556 mm. So the value of our x sub g this one, reckoned from the y-axis, is 35.556 mm. So we already made use of step 3, and right now we need to solve for step 4. And what is step 4? So step 4 is simply to solve for the distances from the center of gravity to the location of our respective rivets. So I'll show you what is in step 4. Step 4 is simply this one, r, that is from the rivet to the center of gravity. So here, this is our center of gravity. So R1, we can just simply assume that since this rivet and this rivet is located 80 mm above and below our x-axis respectively, so we can just simply say that this is our R1.